fast.
Kilauea is studied with sensors. Providing researchers with a constant flow of information as to how the flank is moving and changing.
It's hard to say whether Kilauea's south flank would be one of these catastrophic failures or whether it's just going to creep along as it is now. A flank failure is something that's so big as, for me, to be incomprehensible. It's like an asteroid hitting the Earth. I have a hard time wrapping my mind around just what might happen if that were to occur.
It may be hard to comprehend, but evidence suggests that it's happened before. Flanks have fractured and collapsed, triggering monster waves that feature in the nightmare La Palma scenario. A mysterious feature has been found on another Hawaiian island. Mountainsides, around 1/3 of a kilometer above sea level, are covered with the remains of ancient coral reefs. How on earth did they get there?
I think the mystery with the particular deposits we're talking about in Hawaii is that they're just so bloody large. I mean, these are not small deposits, and because of that, I think a lot of people had a hard time wrapping their head around the size of it.
At first, it was thought that the reefs were fossils left over from a time when sea levels were higher, or that they were lifted from an ancient seafloor by volcanic activity. But the fragmented and fractured corals appear to have been thrown onto the mountainsides. It points to an ominous alternative. Perhaps the smashed coral was hurled onto the mountain tops by a giant tsunami surging overhead. Other clues were waiting to be found on the sea floor surrounding Hawaii. Researchers found a massive mound, a geological formation spanning more than 8,000 cubic kilometers. At first, it was thought to be an underwater mountain. But now, it's accepted to be the remains of a massive volcanic landslide. An epic geological event of an enormity that's difficult to comprehend. The Mount St. Helens eruption in 1980 was the deadliest volcanic event in modern American history. It sparked the largest, most violent landslide ever seen. But St. Helens was a kiddie's sandcastle compared to the ancient event off Hawaii. The Hawaiian landslip that dumped a mountain of rock onto the sea floor was 400 times bigger.
There's the event. You have the initial wave. Huge wave hits the west coast of the Big Island. It dropped a big hunk of the island of Hawaii under the seafloor. It's moved off, drops in. There's a bit of projection out.
Computer models reveal it would have produced a series of tsunami waves that drowned the Hawaiian Islands.
And over here you see the island of Lanai, about half of it.
Many experts think the waves tore coral reefs away from the sea floor and dumped them onto the mountaintops of surrounding islands. But the age of the landslide would have to match the age of the elevated coral deposits. The thickness of marine debris lying on top of the submerged landslide would help calculate when the disaster took place.
Think of it like dust on an old piano. It accumulates, and you can figure out how long the piano's been there because it's got so much dust on it, right? And you can do the same thing with these big landslides.
Analysis of the coral could also tell how long it had sat on the mountainsides. Sure enough, the estimated dates of the landslide and many of the coral deposits were the same.
All the evidence points towards large tsunamis, very large tsunamis. That's the only thing we can think of that would produce this. It's not a debate anymore. It's for sure a tsunami deposit. What else could it be?
It was compelling evidence that volcanoes can trigger tsunamis. And more evidence supporting the theory continues to be uncovered. A growing number of experts are warning that the threat of another flank failure on La Palma should be taken more seriously.
Volcanic flank failures have not been on the radar as much as other types of phenomena. People know that there's earthquakes and earthquake-generated tsunamis, but in fact, they're not even the biggest tsunamis. Compared to what we study on these volcanic flanks, they're kind of small. We're sort of waiting for the next one.
The exact cause of a volcanic flank collapse is still a mystery. It could be gravity simply pulling on the sheer mass of fractured rock, or magma permeating cracks and fissures that push it free. Another answer may lie in one of the most unnatural and inhospitable environments on Earth, the heart of a volcano. Back on La Palma, Simon Day and Steve Ward made their way into the dank recesses of a dormant volcano. Tunnels have been excavated to access reservoirs of fresh water. The sleeping volcano is the island's primary water source. But this life-giving resource may also signal a deadly threat. It's this water that could ultimately push the western flank of the Cumbre Vieja into the ocean, triggering a mega tsunami. Cumbre Vieja is saturated with water, capped by thick layers of ash and rock. Lava sheets, or dikes, trap the water from the side like a rocky seal. If this water becomes heated, it could spark a catastrophe.
These dikes within the volcano are trapping water between them. Then another eruption occurs, more magma is coming up through. The magma in the new dike is very hot, 2,000 Fahrenheit. So it heats the water. If the water was able to escape, it would just flash to steam. But of course it's trapped between the dikes. So it's like the water is in a pressure cooker. You heat the water, the pressure goes up. And it's that extra pressure pushing on the rocks to either side that we think is going to be the cause of the flank of the volcano eventually collapsing in some future eruption.
Very porous material, there's lots of water in there, and so when the dike comes in, heats it up, there's a big pressurization.
Pressurized water could be the catalyst for the landslip that creates a mega tsunami, and La Palma's ancient Cumbre Vieja volcano may be already on the move. La Palma's Cumbre Vieja volcano reawoke with violence in 1949. The month-long eruption blasted craters and sent waves of lava into the sea. The south of the island was rocked by massive earthquakes. The Hoyo Negro crater is a stark relic of the 1949 eruption. But it also contains other, more alarming evidence. The western side has dropped measurably towards the sea,
And if you look there, you've got that yellow ash layer with the black band in the middle of it, and you can follow the black band along the cliff face, and then it drops down 6 feet to the west, and you can see it cutting the little black bands of ash all the way down the cliff face.
The western side of the volcano appears to have been cut free from the island, possibly severed by a fault that runs for more than 3 kilometers along the mountain ridge. Much of the fault is buried under rock and stone. But other parts are exposed, like gaping wounds in the earth. The western sides of these stony wounds are always lower than the other sides.
It's exactly the same as before. The western side here has gone down by a couple of meters relative to the east side here, so we're seeing the same sense of motion on the fault structure. It's all in a line.
Those who doubt that La Palma's volcano is splitting up say it's not a fault, but a surface crack. But geophysicists Stephen Ward and Simon Day point to compelling evidence.
So in fact, it happened during the earthquake. It's long and straight. When you walk along that crack and measure one side to the other, you get a consistent offset and a consistent sense of direction. As an earthquake seismologist, that's very convincing.
They say that if the fissure was a mere crack, there should be more all over La Palma. To these investigators, Cumbre Vieja is vulnerable. They're sure that a collapse is inevitable. Some of the most compelling evidence can be seen from the air. La Palma is an open, sprawling record of dramatic geological change. Jagged peaks and giant holes have been blown into existence by extreme volcanic violence. Could this speck of rock in the Atlantic really cause global devastation? Those who are convinced that it's just a matter of time say it's part of a process that began long ago. La Palma was once dominated by another volcano, Cumbre Nueva. It erupted more than 500,000 years ago, changing the face of the island. After the collapse, a series of vents emerged, creating 3 rift zones. As lava was injected into them, the rift zones swelled into the Cumbre Vieja. Critically, the western flank formed over rubble, the remains of the ancient Cumbre Nueva volcano. It makes the western flank inherently unstable. Over time, the series of vents on either side of the volcano have become inactive, apart from one simmering strip running north-south along the ridgeline. It's the only outlet for a future eruption, and that could tear the island apart. It's an ominous pattern that can be seen time and again in the geological record, a pattern that precedes an eruption and collapse.
Right, so Steve, what we're doing now is we're flying up the north-south rift zone, and this is the one that's active now. So what we can see here is Crater Alfraili, Hoyo Negro, Nambroke, all defining this north-south line of volcanic vents that's cut north through the volcano over the last few thousand years, and that's all part of